Hello, everyone. My name is Glikson. I'm from Spot by NetApp. I'm Chief Architect. This one is going to be in English. And this is not going to include a demo, so sorry about that. I'm going to talk about cost optimization in cloud and in Kubernetes in particular, and how we are using machine learning to do it better. I'll talk about 3 topics in the upcoming few minutes. First, a brief distinction between cost reduction and cost optimization. Then I'll dive a bit deeper into the different aspects of cost optimization in Kubernetes, some challenges, trade-offs, and so on. And lastly, I'll talk about machine learning and how we use the data that we collect from the environment to do the optimization much better in our product. So let's start with the first one, cost reduction. So when people talk about cost reduction, they usually think about money, but it is typically not the only thing that they care about, because if you just want to save money, okay, stop paying and you'll save money, but you typically have other things that you care about, like your application, you're keeping it available and performant. So it's typically there are many trade-offs that you need to manage to actually achieve optimized cost for your applications. So those trade-offs are essentially what I'm going to focus on in the upcoming few minutes. Okay. So the previous slide was created by marketing folks. It's really nice. This one is mine. This is the kind of slides that I typically create. Sorry about that. So there are many different aspects of cost optimization, and I'll briefly go through them. And well, there are many solutions, so many of those aspects can be handled manually, and it is typically useful to have some tools to help you do those things. And well, Spot is one of the companies that is many years in this area and is providing solutions to solve many of those problems. So let's briefly go through them. So the first group is essentially visibility. If you want to optimize cost, you should better know how much are you paying for what is the breakdown of your cost, because if you can't monitor something, you can't optimize it. Okay, so that's the baseline. On top of that, doesn't really matter what kind of optimization technique you use. You're paying to, well, in my case, I'm talking about cloud-based workloads, so you're paying to a cloud provider. And cloud providers, they offer various discounts so that you can use essentially the same hardware and use less for it. So that's something that this is one of the key areas that companies can invest to save cost, to start using Spot instances, for example, which are the same VMs, just the only catch about them is that the cloud provider can take them back when they need it. So your application needs to be ready to be interrupted. But if you do it right, you can save a lot of money, like 80% or even more. And another aspect of that is you can just use some volume discounts, like reserved instances and service plans are mechanisms that the cloud providers offer that you can pay less for the same capacity that you're using without any changes to your application. Now the next group of techniques related to managing the cluster that your application is running on, in this case a Kubernetes cluster. So there are many known techniques. One is to add nodes or remove nodes as your application grows or shrinks. The auto-scaling, so-called, this is a horizontal aspect. there is also the vertical aspect of right-sizing the individual nodes. So depending on your application, the different nodes, it might make sense to have different nodes of different sizes. And the third aspect is, once you have your nodes, how much applications you actually allow to be provisioned on those nodes, whether you have some level of over-provisioning for your applications. So there are different dimensions here and different ways to reduce the actual capacity that your cluster has to run your workloads cheaper. And the third area is more on the application level. So once you have your nodes, now you have lots of different groups of pods running on those nodes. So at that level as well, you can look at horizontal scaling, which is, well, if you're using Kubernetes, you're most probably using that already, the HPA. So based on the load, the Kubernetes can add replicas of your application or remove replicas. In many cases, it works well. In some cases, it doesn't work so well because maybe your load is not evenly distributed between your replicas, or maybe the bottleneck is not CPU or memory. But in general, it's also a very common practice. In addition to that, you can also scale the individual pods vertically, depending on how they are actually using the CPU and memory and other resources. And the third example here is about looking at resources which are not CPU and memory. It is quite common, especially in large-scale environments, to have network as one of the major cost factors. And historically, network is not a resource that is managed as tightly as others in Kubernetes. So it's often much more challenging to even understand that half of your cost is actually traffic between availability zones. And incorporating that into your overall optimization approach is also quite challenging. So those are the different aspects that the DevOps teams often need to tackle with in order to optimize their cost. And well, Spot is one of the vendors that, as I mentioned, we spend a lot of time with customers helping to solve those problems in the different areas. And how do we do that? So one of the mechanisms that we have is to learn the different behavioral aspects of the environment. And when you understand better the behavior, it is much easier to do the optimization decisions. So things that we are focusing on, for example, the behavior of the spot market. So those spot instances that I've mentioned, they have different prices and different availability and different times. So it's very useful to know that maybe one market is good for today, but tomorrow maybe you need to replace your nodes from using certain instance to using another instance, maybe in a different availability zone or maybe even different instance type with similar characteristics. And also at the application level, essentially, the better you understand the behavior of your application, the better you can figure out the resource allocation for it, and also how to translate the load patterns into the underlying infrastructure that you are provisioning. And here there is an example of how we use what we call a market score, which is a score of availability of the different spot markets, which is the graph in green. So this is the market score of a particular market. And the graph in red are the actual interruptions that we observe from the environment. So you can see in this example, so it's a bit simplistic, but hopefully it will give some insight of what we're doing here. So you can see here that the drops in the score precede the actual peaks in the interruptions by a certain amount of time. And this is the kind of things that is very useful to do the optimization better using the lots of data that we collect both from the cloud providers and from the actual machines that we are running. And that's it. Thank you very much for your time. You're welcome to approach me or my colleagues at the booth from NetApp if you have any questions or thoughts about this, or if you want to consider using our product to help with some of those challenges. Thank you very much.